This video is looking at how we draw ray diagrams for reflection. And this is really the most basic type of ray diagram you could be expected to draw, either in an exam or a practical, which you'll do in lessons. So first of all, I'm going to draw my diagram in pen so that it stands out clearly on the video. But when you're doing this in class, it's really important that you do this in pencil so that if you make mistakes, you can correct them very easily. So to do this experiment, you need a ray box with a slit, and we're going to use the single slit for this experiment, which you just slide into the end of your ray box. You need a protractor, you need a mirror, and a ruler as well is helpful. So first of all, what we do is we start by placing our mirror on our piece of paper and drawing along the back of the mirror like so. Then what we do is we indicate the back of the mirror with lines at a diagonal. So these lines here just show that this is the back of the mirror, and therefore this is the reflective side. Okay. Now what we're going to do is we're going to investigate what happens when we have our ray of light and it shines onto our mirror, but specifically when it shines at an angle. So I'm going to just rotate this and move this to here. I'm just going to tilt my mirror slightly forward so you can hopefully see this ray of light sort of coming in and out of focus. Okay. Now, first thing is wherever you fire it onto your mirror line, you want to keep that consistent. So I'm just going to put a little mark here. So I'm always going to fire my ray of light at that point for a second. And what I need to do here is I need to draw where the point I'm firing at on my mirror, I need to draw an imaginary line called the normal. Now the normal is a line that we use to measure our angles. So what I have to do with my protractor is I have to make sure that my normal is a 90 degrees to the surface. So what I do is I line up where it says 90 along the surface of the mirror here, and put my protractor on that point where I'm going to fire my ray of light. And then because I now know that this is perfectly 90 degrees, I draw a dotted line or a dashed line at 90 degrees to the surface. That is my normal. So this line here is called our normal line. And that line is really important because we're going to draw all of our measurements in reference to it. So what I do then is I have my ray of light coming in, and all I need to do is make two marks. So I'm just going to put one little mark here, one little mark there, and I do the same with my ray of light coming out. It's very important I don't move at this point. So I'm going to put one little mark there and one little mark there. Okay. So then what I do is I can turn my light ray off. Okay, move it out of the way, and I need to join up these lines to the point which I was firing at, like so, and like so. Okay, and we always show an arrow to show direction. So this is the ray of light that came in, this is the ray of light that came out. So this ray here is called the ray of incidence, which means it's the ray of light that comes into my mirror, and this ray here we call the ray of reflection because it's the reflected ray. Now what I need to do in this when I'm doing this experiment is I need to measure the angle from the normal to the ray of incidence and the angle from the normal to the ray of reflection, which we call theta I and theta R. Theta being the Greek letter for angle. Okay, so we have the angle of incidence and the angle of reflection. So I use my protractor to do that. So for my ray of incidence, what I'm going to do is I'm going to put the center point of my protractor on the spot where I fired my ray and make sure it lines up. This line lines up with the normal. Okay, so if I just move it in and out of focus, you can see I've lined that up with the normal. And then I just simply read round how many degrees that is. So my ray of incidence is here. So you can see that that is saying that that is 24 degrees. Okay. So So my angle of incidence is equal to 24 degrees. What I'll then need to do in my experiment is measure this angle and see what it is. So what I'm going to do is again put my point at the centre, line it up with my normal, and this time I need to, just because of the way my protractor works, I need to use this measurement on the inside to take it and measure what that angle would be. So in your experiment, that's what you're going to do. And what you should find is that your angle of incidence and angle of reflection should always be the same, and that's called the law of reflection. So this is our basic ray diagram for reflection, where we have a mirror, we draw on our normal 90 degrees to our surface, we then put points in for our ray of incidence and ray of reflection, and then measure two angles using our protractor.